Okay, we've been working with exponents for the last 3 lessons. So now we're going to deal with the division property with exponents. So this part, the division property with exponents, says a to the m over a to the n is a to the m minus n. Okay, so we've learned when you multiply, you add exponents. So for example, x to the second times x to the fifth is x to the 2 plus 5 or x to the 7th, because what it means is there's 2 x's times 5 x's, that's the total of 7 x's being multiplied. Well, now we're going the opposite, we're going division. So if we have a to the 7th divided by a to the 3rd, what this tells us, this property tells us we're going to subtract. So we get a to the 7 minus 3 or a to the 4th. Now here's why. That a to the 7th would mean a times a 7 times. A to the 3rd would mean a times a times a. A in the top divided by a in the bottom gets us 1. A in the top divided by a in the bottom gets us another 1. A in the top divided by a in the bottom is 1. That leaves us 4 a's being multiplied. Those 4 a's is why we have a to the 4th. Now I'm going to show you these two in an example here. If you can get these two, you can get a majority of today's lesson. These aren't on there. So just watch for a moment. Okay, what we do when we look at these, if we understand there's 9 a's in the top, 2 a's in the bottom, what we always do is we subtract 9 minus 2. This bottom one is a little bit different. You still subtract. So technically what you should do is go 3 minus 10. So that becomes x to the negative 7. It'd be x to the negative 7 on top. Then we move it to the bottom and we get x to the 7th on the bottom. But there's a little faster way to do this. If you can simply recognize where are there more. Since if I started with this same problem and I said there are more on the bottom, so I'm going to go 10 minus 3 and get 7, that's okay, but you have to remember if you start on the bottom, then the 7 goes on the bottom. And then there's a 1 on the top, because 10 minus 3 isn't what we have. The rule is you take the top number, subtract the bottom number. You can do the bottom, subtract the top, but then the answer goes in the bottom. Now, I could do this one the same way. I could do this one going bottom minus top. But if I go bottom minus top, I would get a to the negative 7 in the bottom, and then it would move it back to the top, and I'd have a to the 7. No matter what you do, you should get the same answer if you do the mathematics right. Okay? So, going into the examples, here we have 5 of them on the top. Divided by that, we would have y to the 5 minus 4, or y to the 1. But the simplest way we can write it is just y. That would be y on the top, and it is y to the first power. This next one, to do it the long way, you take 3 minus 9, you get negative 6. Then you move it to the bottom. But if you recognize there are 6 more in the bottom, then you understand it much more quickly. Okay, now this next one. I am going to do it the way I'm showing you, but I'm going to tell you there's something I usually do that helps students understand this one better. So this one, if we go with the rule of subtraction, the a would be negative 3 subtract 5. So the A is to the negative 8. The B would be 7 minus 2, which is 5. Now in the end, the A is going to move down. We're going to have 8 in the bottom. So many times when I start out with negative exponents, they get kind of tricky. So I advise students instead on this one to first move any negative exponents to the opposite place. That's what the negative exponent does. So if I move the 3 down, then we would have B5 because the 7 subtract the 2 leaves us 5. These 3 plus 5 is B to the 8th. I did. So let's come back to C. All right, so this one, there's K to the 5th. There are more J's on the bottom, so it's J to the 3rd. Of course, you can stay with the rule. It's K5, and then J negative 3, because you take 2 minus 5, and then move the J down. Okay, we always subtract. All right, in E, first, I'm going to go with the rule. I'm going to go with the rule that we're going to move the exponents. So I moved the 1 down, I moved the 5 up. The Z's, I'm going to leave them. Remember, that's a Z1. Now I'm going to do the subtracting. Now with the X's, 4 minus 4 is 0. So it'd be X to the 0. Anything to the 0 is 1, so those just disappear. The Y to the 4 is in the top. The Z to the 5 is also in the top. Okay, another rule we learned this week. If we add X to the 2 and we raise it to the 3rd power, then we multiply. That's different than X to the 2nd times X to the 3rd. That's X to the 5th. We add the exponents because that means there's 2 X's times 3 X's. The second one underneath here, this means there's 2 X's times another 2 X's times another 2 X's. That's 6 X's because we do it 3 times. Well, we have a similar rule here with quotients. If we raise it to a power, we again multiply. So the top becomes X to the 6th. The bottom, Y to the 12th. So it's not really a new rule. It's just an extension of the same rule. So this one becomes Z to the 12th over 5 to the 3rd, but we don't leave it that way. We grab our calculators. If you don't have one, now would be a good time to get a calculator up here. And okay. 5 raised it to the 3rd power. You get 125. I just took 5 to the 3rd power.
Oh.
Okay. So x to the 6th. Remember that 2 multiplies the 3 on the x by 2, so it becomes x to the 6th. But the top, we take our calculator, we put 4 squared in, 16 over x to the 6th. Now there's a couple ways to do this next one. First, we can just continue doing what we're doing. I'm going to tell you there's a faster way on this one if you recognize it. But we can go a to the 21 over a to the 15. Now, since they're the same, we'll subtract. We'll take 21 minus 15. We'll get a to the 6th. The faster way could be first to say, well, that's 7 and 5, so that's 2. And 2 times 3 is a to the 6th. They both get us the same answer. You could reduce inside first. Technically, if we follow the parentheses, exponents, multiply, divide, addition, subtract rules, the order of operations, that's technically what we should do. We should do stuff in parentheses first. Okay, this next one, D. 2 over y to the 4th to the negative 3. Now, many times when you get the negative exponent, it's going to take just a little bit longer. So I'm going to write 2 to the negative 3 over y to the negative 12. Now, my advice, the way I usually teach students to do this, is get rid of the negative exponents first and then do any multiplying. So in getting rid of the negative exponents, I'm going to move the 2 to the bottom. It's going to become a positive 3. I'm going to move the y to the top. It's going to become a positive 12. It will make it easier if you follow this pattern of getting rid of the negative exponents. Now, take 2 to the 3rd, and 2 to the 3rd in the calculator is 8. Next one. See if you can try the next one. I'm going to give about 30 seconds here. Make sure you're giving it an attempt. So first we multiply. Now we'll get rid of the negative exponents. I'll move the 3 to the bottom, the d to the top, change them to positives. Now I will take 3 to the 4th power, and if you got 81, you have that one correct. Okay? Okay, so this next one, same thing, but we just have a little bit more to do. 6 to the negative 2, x to the negative 4, y to the positive 2. The negative 1 times the negative 2 is a positive 2. So first, all I did is take the top, multiply them by negative 2. 2 to the negative 2. X to the negative 2. Y to the negative 6. So if you follow these rules, it's usually much simpler. You can sometimes get there faster if you learn how to do it, as long as you follow mathematical steps, and you can get there faster, that's great. Okay, but now, I'm going to move everything. I'm going to get rid of the negative exponents. So the first thing I'm going to do, now don't write this, everybody. I'm going to do this in a faster step. So if you can't handle it, then you may want to write more steps. So watch for a moment. If I move the 6 down, it's going to be 6 squared. I'm moving this to the bottom. But I'm not going to write 6 squared. I'm going to write 36 because that's what 6 squared is. So if you can't handle doing it that fast, then you need to do it a step slower. The 2 squared, I'm not going to write 2 squared up here. What should I write? 4. I am trying to save a little bit of time and do the steps a little bit quicker. Now the x4, I'm going to move down here. The x2, I'm going to move up here. The y2 stays put because it's positive, but the y6 moves up because it's negative in the bottom. Now I have to put some things together. So grab your calculator and type in 4 divided by 36. I'll assume you can do that. 4 divided by 36. And it should get you from the calculator 1 over 9. Is that what it shows on your calculator? Now, those of you who are watching, either here or at home, are saying, why didn't he write the 1 on top? Because I want to see if there's anything on top with the 1 first. So 1 over 9, there's a 1 up here, but I didn't write it yet. There's 4 x's in the bottom, 2 on the top. If I subtract them, 2 minus 4, I get x negative 2. But then I would turn around and move it to the bottom, and it'd be a positive 2 on the bottom. Or I can take 4 minus 2, but since I started in the bottom, I have to put my answer in the bottom. y2 and y6, if I put those together, we get y to the 8. Now, that's the reason I didn't put the 1 in front of it, because I wasn't sure what was going to happen. There is still a 1 there. I don't have to write that 1 times it in there. That's why I didn't start with the 1/9. I just waited till the end. But I put the 9 in the bottom originally. All right? Next, part B. Step at a time. This becomes x to the negative 6. In the bottom, it becomes y to the positive 4. Now this says times. I'm going to tell you, if you are multiplying, you can just extend it, and they're all on the top or all on the bottom. And here's the reason why. Back when you learned some fractions in grade school, all this means is you multiply 2 times 3 and 3 times 7, and you can have 6 over 21. And back in grade school, you might reduce the fraction and divide them each by 3 to get 2 7s. But the numbers on the top get multiplied the numbers on the bottom. So I'm just going to extend my fraction bar here. I have a y4, I have an x2, and I have an x1 that got moved to the top because it was negative in the bottom. Now, since there isn't much work here, I'm going to cheat the system a little and just move this x to the bottom. It's the only negative, so I'm not going to rewrite everything. Does that make sense? Now we'll start working with these. The y's. y4 over y4 becomes y0, which is just 1. Anything to the 0 is 1. The x's. There are actually 3 x's up here, and there are 6 in the bottom. Which means when all is said and done, there are only 3 in the bottom.